this video, you're going to look at what causes a material to change state. You will consider why materials change and what that change actually means at a particle level. Take a look around you. You're surrounded by 3 physical states of matter. Of those you can see, many will be solids. The ground you're standing on is likely to be a solid. Some of the things around you will be liquid. Look up into the sky. Do you see any clouds? Perhaps it's raining where you are. Water is the most common liquid covering most of planet Earth. Try moving your arms and hands quickly around you. What do you feel? This is a mixture of gases called air. You cannot see gases, but you can see their effects. Materials of all types can be changed into solids, liquids or gases by changing their temperature. In a solid, the atoms that make them up are tightly packed together in a lattice of rows and columns. The bonds between the atoms are strong. This is why the solids around you remain in a fixed shape. If you can imagine the atoms in a place like a regiment of soldiers on parade, you would see them vibrate from side to side whilst in their fixed position. Imagine heating the solid, raising its temperature and giving each particle more energy. The particle vibrates more and more until they have enough energy to break out of the lattice. The bonds will break and the atoms begin to move around much more easily. The substance will change into a liquid. With more energy, you can imagine the atoms moving freely around like dodgem cars at the fair. This change is called melting. If you continue to heat the particles, they will gain yet more energy and move more freely. The atoms spread out. Now free to move, the particles move right away from each other. Imagine the particles whizzing around at great speed. The space between the particles is very large, and the bonds now non-existent. We call this evaporation. All the changes that you've thought about will go in the opposite direction if a material is cooled. Where spaces between particles got larger on heating, on cooling they become closer together. Just take a moment to breathe on a window. What do you see? The air you breathe out is warm and moist. What you see is condensation as the air cools on the colder glass. If you place a glass of water in a very cold place, the water will quickly cool and the liquid will become solid. This we know as freezing. So in summary, the physical state of a material is dependent on the energy the particles that make it up have. The more energy they have, the smaller the bonds between them and the more they move about. Each material has its own melting point and boiling point. These are key temperatures where a material will change state between solid, liquid and gas.
Alright, I've watched the video.
Yeah, jolly good. Right, let's get the thing up again. Okay. Right. A bit more about the particle theory that I was talking about here. So what it's saying is that we can explain the properties of solids and liquids and gases by understanding how the particles are arranged in each of those types of things. So in a solid, the density is high because all the particles are packed together. We can't squash them, we can't compress the solid because there's not much space for squashing them because the particles are all close together. They've got a fixed shape because the particles are all attracted to each other and they hold each other tightly. And they can't diffuse. I'll come back to diffusion in a minute. Okay?
Yes.
Okay, so in a liquid, we're still fairly dense because the particles are still pretty close together. Because the particles are pretty close together, we still can't squash a liquid very much. They can take up the shape of whatever container they're in because the particles can move around and flow. And they can diffuse. Again, I'll talk about diffusion in a second. Okay? And then with the gas has got a really low density because those particles are a long way apart from each other. You can easily compress them. You see that in the syringe or whatever. And they don't have any old shape. They can take up whatever shape of the container you've got them in. And they can also diffuse because the particles can just move around, okay?
Yeah.
Okay. You got any questions about any of that?
No.
Okay. So this is just like summarising that. So the difference between the solids, the liquids and the gases, we can explain by looking at what the particles are up to that make them up. So all of the substances are made of particles, and the particles are attracted to each other, but some particles are attracted more strongly and some more weakly. And the particles can move around because they have what's called kinetic energy. And the hotter something is, the more kinetic energy it's got. So, but the particles in the solid, they can only they've got some energy, so they move, but they just kind of jostle around slightly within their fixed place. In the liquid, they can move around more, which is why they can flow. And in the gas, they've got lots of energy and they're pinging off all over the place. Okay?
Yes.
Right. So, let's talk a little bit more about the gases because they're quite fun, aren't they? They're the ones that can change shape and everything, change volume and everything.
Yeah.
So, with gases, scientists talk about something called gas pressure. Okay, and the pressure is. Do you know what I mean by pressure?
Yes.
In general, how would you describe pressure for me?
So, say something like, let's just get a gas. If you want pressure, it's like you're applying pressure. Like if you're a solid, like pushing it onto it.
Exactly. Yeah.
Make pressure.
That's right. So when they talk about gas pressure, they're talking about how the particles in the gas are pushing on the container that they're in.
Yeah.
So if we imagine here, we've got this cube of gas and it's got all these pink particles whizzing around in it. Because they're flying around all over the place, every now and again they're bumping into the wall of the container and that's causing pressure on the container.
Yes.
So, but there's like millions of them in there doing it. So the gas has a particular pressure, and the pressure comes from the particles hitting the walls of the container. So here's an idea. If you heated up the gas, what do you think might happen to the pressure?
The pressure would stop. It would get lower.
Why do you think that?
Because it could be like weakening it.
Okay. Weakening it. Okay.
Because
So if we put heat into something, heat gives you more energy.
Yeah.
So if we gave more energy to those little particles,
It would get higher.
higher, good
Higher
man,
density.
yes. Because if we give, I'll show you on the next slide. If we have this container and it's got our gas in it and then we heat it up, the gas pressure actually increases, and that's because we give more energy to the particles, and so they're whizzing around more, so they're hitting the wall more often, That's more pressure. And also, because they're moving faster, they hit the wall of the container harder as well. So those two things mean that the pressure that the gas is putting on the container has actually gone up, because we've given them more energy through the heat. Okay?
Yes.
That makes sense now?
Yes.
Okay. And then there's another thing. Do you remember, obviously we can squash gases. So if we squash the gases closer together, gas particles, that increases the pressure as well. And that's just because if the particles are squashed into a smaller space, they hit the wall more frequently, because they don't go very far, do they, to hit the wall. So this is showing it as an illustration on the side here. So you could imagine this being like a bicycle pump with a gauge on the top. So when we push the pump in, what we do is we squash the particles of air together, and that means that their volume is less, but the pressure goes up. And then if we pull the pump back out, we make the volume bigger again, so the gas will spread out again and the pressure gets less.
I have a question.
Absolutely, go on then.
You know how you said once you take it back out and the gas forms, how does the gas form back when you...
Right, okay, so in actual fact, you could try this with a bike pump if you got one. What happens is you push the bike pump in, so we're doing work, we're having to do work to squash that air back down into a smaller volume, and the pressure goes up, okay?
Yeah.
If you just let go, what you should find is you don't actually have to do anything. The plunger on your bike pump will automatically start coming back out again, okay?
Yeah.
And that's just because the gas is at a high pressure. All those little gas particles are hitting against the inside of your plunger in here, in this area. Okay, so they're all banging around here, and they're actually hitting. Oh, why is this not working today? Okay, so they're hitting the plunger here, and that actually pushes the plunger back out as far as it will go. So